In this video, I'll show you how to solve motion of a point problems with derivatives. This is question 4 in the series. The question reads, a point moves along the curve y is equal to 2x to the power of 3 minus 5x squared minus 1, and the units are in centimeters. In question A, they ask us to find the direction of travel at x is equal to 2.00. To find the direction, we first need to derive this equation so that we can find its velocity. Remember that velocity is a vector quantity, which tells us the speed and direction. Once we evaluate the function at t is equal to 2, we can then find the vector components by using trig ratios, and that will lead us to finding the direction. I'll explain it in more detail once I find the first derivative. So I have y prime, which represents my first derivative. 2 times 3 is 6, x squared minus 10x. You should know by now how to find the derivative of these terms. I've used the power rule for both. This term became that term, and that term became negative 10x. So to find the velocity at 2 centimeters, I now will substitute x is equal to 2 into this equation. 6 times 2 to the power of 2 minus 10 times 2. 2 to the power of 2 is 4 times 6 is 24 minus 20, and that gives us 4 centimeters per second. What does this mean? Well, I've gone ahead and plotted the original equation, and it looks like this. At x is equal to 2, here's x is equal to 2, we have a point. And what's happened is if we draw a tangent line right now along this point, and it's a perfect tangent line, and if you find the slope of this tangent line, you should end up with 4. So the slope of this tangent line, m, is equal to 4 centimeters per second. And we've also defined slope in the past as rise over run. Rise over run. So our rise is 4, and our run is 1. You can actually picture this as a right triangle, where 1 is the adjacent length and 4 is the opposite length. This and this would represent the adjacent and the opposite along this angle, which we'll call theta. So if we take tangent of 4 and 1, tangent theta of opposite of 4 and adjacent of 1, and we find tangent inverse of 4, we will end up with our angle. Using our calculator, tangent inverse of 4 gives us 76 degrees. Therefore, the direction of travel when x is equal to 2 centimeters is 76 degrees. In question 2, they ask us, if the speed v of the point along the curve is 3 centimeters per second, find the x and y components of the velocity when x is equal to 2 centimeters. So this time they tell us what the velocity is, and it's 3 centimeters per second. That's essentially your m value, the slope. Whereas before our m value was 4, and what they want is the x and y components of when the slope is 3 and when x is equal to 2. So the angle we have to use is 76 from what we found in part A. So to find the x component, which I'll denote as Vx, we'll take our slope, which has been given as 3.00, and multiply it to cosine 76. To find V sub y, we'll take 3, our hypotenuse, times sine of 76. This is how you resolve the velocity vector, v. Let's use our calculator. 3 times cosine of 76 gives us 0.726. So Vx is 0.726 centimeters per second. And Vy, if you do the calculation here, should give you 2.91 centimeters per second. So there you have it. That is how to solve motion of a point problems with derivatives.